All right, this is Module 5, Lesson 3, or I'm sorry, 13. We're going to be talking about selecting a good sample. So yesterday, we learned how sampling is a central concept in statistics. Examining every element in a population is just usually impossible. So instead, we refer to samples from a population. So let's think about how to choose a sample. All right. If you select a sample that accurately represents the entire population, we say that this is unbiased. If a sample has one or more parts of the population that are favored, we call this a biased sample. So when you're talking about things, you want to be unbiased. You want to accurately represent the entire thing. You don't want to lead our results in one direction or the other. So let's look at this first example. It says a TV programming manager wants to conduct a survey to determine which reality television show is the favorite of viewers in a certain area. He is considering the 3 samples shown. So we're going to draw an X through these 2 samples that would not fairly represent all people in the viewing area. So 100 people that are trying out for a reality show. Is that how we should conduct the survey to see which reality show is their favorite? Well, if you're asking people trying out for a reality show, that's going to be biased towards that reality show. So that's not a good one. All right, how about 100 people at your middle school? All right, well, that's a good example, except the problem is they're all middle school students. So you're not getting any younger kids. You're not getting any older adults. So this would also not be a good representation. If you do every 100th person at the shopping mall, now a lot of people go to the shopping mall. That would be a good, unbiased representation. All right, so let's see whether the conclusion would be valid or not. And this is going to go based on whether you think the sample would be collected would be biased or unbiased. So a random sample of 50 students at a middle school shows that 10 students prefer listening to rock, 15 prefer hip hop, 25 no music while they exercise. It can be concluded that half of the students prefer no music while they exercise. So would this be a biased or an unbiased way to represent what students prefer when they are exercising? Well, we did take a random sample, and it's 50 middle school students. We're only looking at students. So this would be a valid conclusion. And a lot of times when you're looking at a valid conclusion is, does everybody have a chance to answer this? Now, in this case, we are talking about a random sample. So did everybody have a chance of being selected in this random sample? Probably. So a lot of times it's valid when every student has a chance of being selected. If every chance doesn't have a chance, if every student doesn't have a chance of being selected, that would be that would lead to invalid conclusions. Let me give you an example. If you're standing in the 7th grade hallway asking if the whole middle school likes to go to the dance, you're only allowing yourself to choose 7th graders, which would not be a good sample because you're not choosing any 8th graders, you're not choosing any 6th graders. So that would make the conclusion not valid. All right, how about this next one? A radio station asks if its listeners to indicate their preference for one of the 2 candidates in an upcoming election. 70% of the listeners who responded preferred candidate A. So the radio station announced that candidate A would win the election. Would this be valid results? Well, think about this. Did everybody call in, or was it only people calling in for A because they felt so strongly about that? So I would say this would not be valid. Because you're only basing it off of the people that called in. There are so many more callers that you could have asked, or so many more listeners that you could have asked, but the only people that we based it off were the people that called in. All right, so we're going to show an example of how this would work using an in-class activity. I will explain it to you, but we're not going to be able to do the whole thing because it is an in-class activity. All right. So suppose you wanted to learn about the lengths of the words in a poem. I have a poem, a copy of a poem that I've distributed in class. It's called Casey at the Bat. We plan to select a sample of 8 words from the poem and use these words to answer the following statistical question. So on average, how long is a word in this poem? So what would the population be? Well, the population would be all words in the poem. Now, this poem is quite long. It's like a page and a half. So we have a lot of words that we're dealing with. We could count them all up and do it that way, but my guess is that there's too many words. We're not going to do that. So let's look at this poem. In class, I'm having them select 8 words that they think is representing words in the poem. They had to record them here and describe the sample that they selected. Obviously, you can't do that at home because you don't have the poem. Number 3, a random sample is a sample in which every possible sample of a sample size has equal chance of being chosen. So I keep talking about this. A good sample is when everything has an equal chance of being chosen. So do you think the set of words up here was random or not? Now, possibly, depending on how you chose it, but my guess is that you may have used all of the small words, you may have used all the big words, so it's not, every word did not have an equally likely chance of being picked. So possibly, but maybe not. All right, so then what we did in class is I gave them a method that they could make this equally likely chances of being picked. We had 2 bags containing numbers. One would identify the group number, one would identify the word number. They pulled numbers out of a bag, and that's the word that they used from the poem. They collected all of this data, and then they were going to answer the questions that follow. All right, so we recorded the 8 words that they selected. They had to describe their sample. Then we compared the sample from this question to question 4. So question 2 was the one that they picked on their own. Question 4 was the activity that we did with pulling them out of a bag. There is some differences between the 2 samples because one was just randomly chosen, like they just picked them, whereas the other one was every word had an equally likely chance of being picked. All right, so the actual mean of the words in the poem is 40.2 letters. So that's the population mean. That's for the whole poem. It says compare the samples from 2 and 4 to the population mean. So we actually calculated the mean for both and then compared it to the population mean. Do you think either of these samples accurately represent the population? Well, question 4 was the one that we pulled the numbers out. That every word had a chance of being picked, and it came from the population. The other one came from a population as well, but it's just by sight. So I don't think that every word really had an equally likely chance of being picked. State why random sampling is so important. Well, random sampling is so important because you want every word to have the same chance of being picked. All right, and that is as much as we can do on the computer. Like I said, everything else was done in class. The problem set follows. It is all about the idea that every option needs an equally likely chance of being picked. So try those out and we'll check those in class tomorrow. Good luck.